Hi everyone. In this video we're going to talk about reading data to and from R with the readr package. Reading data in and out of R is a fairly simple process. There's a lot of work that goes on behind the scenes, but thankfully readr, the readr functions help a lot. And so quickly, what are we going to talk about? Well, we'll talk about the readr package, the data file types, the read underscore functions, and the write underscore functions. So it's going to be a pretty quick video, hopefully. So, and then I'll talk about any other relevant tips and tricks I have. Okay, and so as always, here's the cheat sheet for readr. Okay, most of it you aren't going to use. There's a lot of stuff on here that you probably never use, but it's here. Okay, and so readr is the tidyverse package for reading data in and out of R. It parses, so readr, what does readr do? What do the functions in readr do? They parse a flat file into a tibble. You'll find that every data set that we're going to use or work with either is a tibble or data frame to start with, or we're going to try very hard to get it to a tibble or data frame because that's what we're going to always try to work with. And so data can come in many different formats, some of them easier to work with than others, and we're going to take all of those possibly good, possibly bad kind of files and try to make them a tibble. That's what readr does. Okay. Outside of the tidyverse, there are a couple of other options. The main competitor, as I said before, for dplyr, if you watch the dplyr videos first, is a package called data.table. It is not as readable, or we'll say easy as dplyr or the tidyverse, but it is generally faster. And then there are the base functions. So R has base functionality for reading files, or it wouldn't be much of a data analysis language if it didn't. But the tidyverse and data table methods, the functions are going to be faster and better than the base R functions. Okay, and so if you need any more motivation other than me telling you that you should learn these functions, is that the base functions can be up to 10 times slower when trying to read in files. And for most things, when we're usually going to work with comma-separated values or CSVs, but when we don't, and we aren't dealing with CSVs with maybe 10,000 rows, we're dealing with CSVs of 1,000,000 rows or 10 million or 1,000,000,000 rows. We definitely won't deal with anything that big. But think of, as it scales up, the base functions being 10 times slower actually leads to a visible delay between the two functions. And of course, we're interested in doing things fairly quickly. So anyway, the readr functions are good. Okay. And then a data table is usually a little bit faster than readr, but it is a pain in the butt, sort of. Okay, so before we get into the actual functions, I thought I'd do a very small refresher of types of files that you might get. You've probably heard of the endings or seen the endings of the files, but I just thought I'd give a small refresher. We're going to deal with a lot of file extensions in this class. So for a regular R file, it's just a .r. You're working with Quarto files, which is .qmd. R Markdown files, which I talked about a little bit, are RMD. There's a lot of file extensions, and knowing what file extensions generally mean, I think, is important. You probably know, but I'll go over it in just a second. The most common data file that you're going to get that's not already ready for you in R is a comma separated value. It's a regular flat file, so like a regular just file with numbers in it, and the numbers are separated with commas, hence comma separated values. But there's also tab separated values, fixed width files, weblog files, and many, many more. And so we need to have methods that will read each of these in. So we'll always hope and pray for a CSV, because a CSV generally works well. But when we have the other types, we have to know how to use them. Okay, so now to the big and important part, the functions that we actually use. So there are read underscore, and then I put a star here to represent that there are many types of them. So the most common function you're going to use is read underscore CSV. But as I said, there's a tab separated value, so there's a read TSV, so on and so forth. A couple different read underscores to help us. And really, what all that read CSV needs, if you look, there are many options inside of read CSV. So the function arguments, there are a lot of them, but they are almost all already have stuff there. Sorry, the word that I I should be using is not coming to mind. Defaulted. So almost all of them are defaulted, except for, of course, the file. Okay, and so the file most commonly is going to be a path to the file on your computer. So maybe you just have to put the name, or you might have to put the path to the file. So the hard path to the file somewhere on your computer, or something like that. But it does more than that. You can also put an entire URL to a website. So a path to a website, or you can even put data in there, in quotes. You probably don't want to do the third part. Almost no one ever does that third part, but the first two are fairly common. Okay, sorry. So here you go, the three examples. So a read CSV, and then the three examples. A path to your file on your computer, a website address, and actual data. Okay. All right, that was read CSV. Now, what if you want to take the data that you just worked with in R and put it in a CSV? So you might find yourself working with someone else who doesn't know R, or you might find yourself working with a data set that you want to use elsewhere. So something that might be common is if you were a data scientist and you were happening to work in multiple languages. So the other main competitor to R, and many might suggest is even more popular than R for data science, is a language called Python, which you technically should know based on the prereqs of the course. But there are other languages, Julia, Observable. There are many different languages out there that do various data science-y things. And so I could, in theory, really like the modeling strategy of Python. So the functions that I need to use to model stuff. If you go on, hopefully you do, go on to Data Science 2, we focus on modeling in that course. Now we're going to do it in R. We're not going to do it in Python. But if you go out, build your own opinion, and you like Python more for modeling, but you like to manipulate data, in R you like to clean the data, munge the data, whatever verb that you want to use. People use a lot of them, and you like to do that in R. It might be helpful for you to do that data manipulation, write it to a CSV file, and then load that CSV file in Python. There are probably actually better ways to do that than that, but that was just the example that comes to mind. Or you might be trying to give a file to someone who doesn't know what they are. Like they don't know R, and they don't want to read some R file that you gave them, or screenshots or something, but they know how to work with Excel, which can open a CSV. And so you might want to give them a CSV at the end outside of R. Sorry, long-winded story to introduce the write underscore file. So as you can see, write underscore takes a lot less options. 2 options, X and then path. X is the data set in R with which you want to write to a CSV. And then the path is the place on the computer where you want to write it to. Excuse me. And so those are the 2 arguments that are required. The rest are defaulted. And write CSV is a little bit more niche than read. You use it a lot less often, but can come in handy sometimes. And that is going to be the end of our reading data with readr lesson.